So good morning to all. Today we discuss about classical mechanics from the last class continuation. So last class நம்ம என்ன பார்த்தோம்னு பார்த்தீங்கன்னா generalized coordinate னா என்னன்னு பார்த்தோம். Then second one transformation equation னா என்னன்னு பார்த்தோம். Then third principle of virtual work னா என்னன்னு பார்த்தோம். So last classல நம்ம என்னென்ன பார்த்தோம்னு ஒரு recap மாதிரி பார்த்தலாம். So last class பார்த்தீங்கன்னா generalized coordinate தான் பார்த்தோம். So generalized coordinate, how to define that should be the independent coordinate are sufficient in number to system configuration, which is called as generalized coordinate. So what is meant by generalized coordinate? That should be it should be denoted by Q1, Q2, Q3 and QK and QF, where F is the degree of freedom or generalized coordinate. So this is the definition for generalized coordinate. Then transformation equation, there should be a Cartesian coordinate x, y, z and position coordinate r. This is called transformation equation. Then principle of virtual work, so the force of the constraint is 0, we have to write then summation I is equal to then Fi into dou Ri, which is equal to 0. If the fractional force is contained, then we have to put Fi is equal to A. So the total applied force is 0 when the system is in equilibrium. So those three topics we discussed in the last classes. Okay, so today we discuss about DAlamberts principle and Lagrangian equation. So today we discuss then DAlamberts principle. So idume most important. So how to define DAlamberts principle? So from the previous cases, the virtual work done by the force of the constraint is 0 in principle of virtual work. But in DAlamberts principle, the force of the constraint is vanishes. That is the important, vanishes. Okay. Up what is the condition from the principle of virtual work? Then summation I, then Fi is equal to rho Ri is equal to 0. So then from this equation, then summation I is equal to then Fi A minus Pi dot then rho Ri is equal to 0. So if you take this is the force of the constraint in this equation. There should be no more activity in this equation. So we can neglect the superscript of the force of the applied constraint. We have to neglect it. So then summation I is equal to then Fi minus then Pi dot minus rho Ri is equal to 0. Okay, so where Pi, which is called as reversed effective force, reversed effective force of ith particle. So okay, so this is called as the DAlamberts principle. So in the equation we have to remember. So narrative okay. So the DAlamberts principle, from the principle of virtual work, in these cases the force of the constraint is 0. In these cases the force of the constraint is vanishes. So from this equation, the force of the constraint is no more active in this equation, so we cannot neglect it. Then remaining equation, which is called as the DAlamberts principle, or sometimes it is called as a dynamics of the system. Okay, good. So next, Lagrangian equation of motion. Lagrangian equation of motion. So then how to write the Lagrangian equation or Lagrangian function? So this is also most important. So in the question la kandipa definitely last or 5 to 6 years neenga question paper edhu pathina adala romba important. So the Lagrangian can be write it as then L equal to T minus V. So how to define the Lagrangian function? So the Lagrangian function L is the difference between the kinetic energy and potential energy, which is called as Lagrangian equation. So it is a function of generalized coordinate q, then generalized velocity q dot and time. Okay, so then Lagrangian function, how to define the difference between the kinetic energy and potential energy, which is called as Lagrangian function. It is defined as a generalized coordinate q, then generalized velocity q dot, then time. Appa how to write? Then Lagrangian L equal to then q comma t, which is equal to then t q comma t minus v of q t. So then Lagrangian represented by the generalized coordinate, generalized velocity, then time t. Okay, so the potential energy and Lagrangian function is a conservative system. So adu mari irundhuchina it does not depends on time. Appo how to write? Then L equal to we can neglect t. Okay, here t. Appo L then q comma q dot, which is equal to then t q comma q dot minus v of q. This is for conservative system. Okay, this is Lagrangian function. Okay, so the Lagrangian function, which is nothing but L equal to t minus v, where t is the kinetic energy, then potential energy, then Lagrangian depends upon the generalized coordinate q, then generalized velocity q dot, then t. So we have to write this equation. So the potential energy and Lagrangian of a conservative system does not depends on time t. So we have to neglect t in this equation. So this equation represented as a conservative system. Okay, good. So next is generalized momentum. எப்படி எழுதலாம்னா so generalized momentum. So இதுவுமே நிறைய டைம் கேட்டிருக்காங்க. Generalized momentum, then Pi is equal to then dou L by dou Qy dot. So this is the generalized momentum. Papa, how to define the generalized momentum Pi conjugate to the generalized coordinate, that is called generalized momentum. So that should be then Pi, which is equal to then dou L by dou Qi dot. Okay, so the generalized momentum Pi is conjugate to the generalized coordinate dou Qy, which is called as generalized momentum. So this is most important. Okay, so okay, I hope it is useful for you, those who are preparing PG TRB. So today we discuss about two topics. One is then DAlamberts principle, another one is a Lagrangian function. So then DAlamberts principle, how to define the DAlamberts principle? The force of the constraint is vanishes. After that, the force of the constraint is also no more acting in the system. So we have to neglect the force of the constraint. Then after we have to get then Fi is equal to Pi dot, then rho R is equal to 0. Then Pi is called the reversed effective of the ith particle. Then Lagrangian function can be written as then L equal to T minus V. Okay, so நம்ம சேனலுக்கு இப்போ தான் வரீங்கன்னா சப்ஸ்கிரைப் பண்ணிங்க. ஸோ இந்த வீடியோ பிடிச்சிருந்தா ஒரு லைக் பண்ணுங்கள், ஷேர் பண்ணுங்கள், உங்கள் சஜஷனை கமெண்ட் பாக்ஸில் சொல்லுங்கள் நண்பர்களே. மீண்டும் ஒரு